Welcome, and in this video course we are looking at the CyberOps Associate version 1 course. This course is going to cover the skills and knowledge needed for successfully handling the tasks and duties, responsibilities of an associate level security analyst working at a security operations center. The goal of this video series is to help prepare learners for the Cisco 200-201 certification that's focusing on understanding the Cisco Cybersecurity Operation Fundamentals course known as CBROPS. Hello and welcome to Module 25, Network Security Data. So in this module, we're going to be looking at types of security data, in-device logs, and network logs. So again, the big thing here, security data, is going to be looking at the types of data used in security monitoring. So know that it says security data, but it's more of a data used in that monitoring section. Alright, so with that said, let's talk about the different types. So we've already did a lot about alert data. We already looked at IPSs and IDSs and networked versions and host versions of IDSs and IPSs. We've looked at things like snort and things like that. Well, snort's going to be one of the big ways for us to filter out our alerts so that we can make something meaningful out of that. Alerts that are generated by snort are made more readable and searchable by using things like Squill and Squirt. These are going to be applications that are part of the Security Onion suite of the network security monitoring tools. So again, we're looking at multi-tools to do our analysis, to do our analytics portion of it. A big part of that is how do we read it though? So here we have a typical session and transactional data log. We have multiple layers. Well, the first area is our session start timestamp. After that, we have our unique session ID. After that, we have the IP address of the hosts. After that, we have the port of the host. Then we have our IP of our responding. And then we have the destination or the responding port. We have the transport layer protocol for that session. We have the application layer protocol. We have the duration of the session, we have the original and responding bytes from the host, and then we have the original and responding packets from the original host and the responding host. And again, we're going to have a lab where we dive into this to do our explanation portion. So in this example, we're looking at a partial output from a 3 sessions dump from our Zeek connection log. And again, like I said, we're going to have a lab looking at our logs in the lab sections. So the session and transactional data, we will have our initial gets and our response. So again, our get is going to be requesting some form of web content, and then the response should actually be the text responding. The transaction that represents the request and reply would be logged in an access log on a server or through a network IDS like Zeek or through Snort. Sessions might include downloading of content or viewing of content through a web server. We could also have a full packet capture, and this is going to be a complete dump. And normally this is where the data is generally collected. It contains the actual contents of the conversation, such as the texts, the emails, the code. Extracting content can recover from a full packet capture and analyze. However, the amount of packets being captured are going to be tremendous. So having to constantly capture all data traffic on a network becomes very cumbersome. Here we're looking at a Cisco Prime. We're looking at the packet analysis tool inside a network analysis monitoring component of Cisco Prime. We also have our statistical data, and that's going to be based off of our behavioral analysis, looking at machine learning or AI, as well as a review of how normal internal users actually do things. Statistics can be used to characterize normal amounts of variation in normal traffic patterns. A NSM tool that utilizes analysis could be Cisco Cognitive Threat Analytics. It's able to find malicious activities that bypass traditional controls. Because it uses advanced anomaly detection and machine learning / AI, the behavioral analysis portion allows for the review of what a typical user would be doing, and it looks for anything abnormal to then flag as odd behavior. Alright, so now let's look at in-device logs. So our in-device are going to be things like host logs, application, system, setup, security, or other terminal-based logs. If you're used to a Windows environment, the application, system, setup, security logs are all pretty straightforward. Because again, these are typically the common logs you find in a Windows environment. In Linux and Mac, there are similar logs, and they're named very similar items. The important part here is to recognize the event type. When we're dealing with any type of log, there will be an event type, and that's the key thing. They're normally broken down into 5 or 7 groups depending on what we're looking at. First is going to be the error, and that's when an event that indicates a significant problem has happened. Warning, that's an event that's not necessarily significant but may indicate a problem. We have information, that's going to be a successful operation or something. A successful audit is an event that records an audited security access attempt that is successful. And then we have our failure audit, and that's going to be an event that is recording an audit security access. The attempt is failing. The audits could be your logging user logins, and a successful user login will generate a success audit. A failed login will generate a failure audit. The big ones are error, warning, information. Those are the key things. When we're getting deeper into our log review, our audit success and failures are going to be increasingly important, but early on they're not as crucial as understanding other types of event types. Alright, so how do we look at our logs via our syslog? Again, the syslog will include specification of the message formats, the client-server application structure, and all of that. The full format of a syslog message has 3 distinct parts: the priority, the header, and the message. All of it combined should be about 1024 bytes. The priority being 8 bits, and the header and message being subjective based off of that. When I said earlier about the severity or the priority sometimes being more than just the 3 or 4, the reason I say that is because there are a clear 8-step severity to our messages, the 0 through 7. And when you're dealing with networking devices, these 7 severities still apply. And they are: a severity of 0 is an emergency, 1 is an alert, 2 is critical, 3 is error, 4 is warning, 5 is notice, 6 is information, 7 is debug. The lower the severity, the more crucial it is for you to look at. And there are facility codes as well. So facility codes between 15 and 23 kind of correlate to a local 0 through 7. These are assigned to different meanings depending on the use context, but again, normally we're going with this 8 levels, 0 through 7, with the lower numbers being the most critical. So how does the severity equate to the priority? So normally the priority value is calculated by multiplying the facility value by a factor of 8. And then you'll add to that the severity. So the facility times 8 plus severity. This allows the priority to be set, and the value is the first value in a packet that occurs between the angled brackets, or the carets. So here we have our access log and IIS type log. These are server-based logs. You'll notice that they are stamped. You have the IP address, you have the dsmith, you have the time, date, then time, then you have what it's trying to do. Here we're doing a GET request. The IIS log is slightly different. It is going to be the date, then time, then address, and then you get additional information from there. Server logs are essentially the source of the data from the network security monitoring. You can also have like a DNS proxy server log, and that'll document all the DNS queries. Two important log files that are access logs from our web server. That's going to be Apache or NX or IIS. Those are the big ones. All of these logs should be dumping into a SIEM, or Security Information and Event Manager. This is a collection platform. This is going to collect logs from our IDSs, our IPSs, our firewalls, our host-based, network-based IDSs and IPSs, our full packet captures, and all of that. And what we're going to get from there is a dashboard. We're going to get reporting, our alerting, our automation. Our reporting features are going to be coming through there. A SIEM can also act in conjunction with a log collection. And again, you'll be using this to collect logs. This will be normalizing our logs, and our SIEM helps to correlate and aggregate our logs. Correlation is basically linking the logs and events from different systems and applications. Aggregating is reducing the volume of events data that are consolidated duplicate events so that you have a more meaningful understanding of the flow of communication. Our report is going to be just that, a report of correlated aggregated event data, and then we have a compliance report at the end. Our SIEMs could be as simple as looking through a dashboard. Here we have Splunk, which is a SIEM and log collection, a very popular SIEM, and Splunk is a Cisco partner. Splunk does have a free certification as well, so you can learn how to use Splunk at a very high level. Because of the lack of cybersecurity professionals to monitor and analyze the large volume set, it's important to realize that a vendor that can integrate into a single platform helps reduce the number of security professionals needed to dive into this. The big thing here is to recognize the integrated security platforms go beyond the SIEM and the SOAR to unify multiple security technologies to a single dashboard. Again, having a security professional with 20 different dashboards doesn't help. Having a single point, having a single connection for a security analyst to review makes all the difference. Alright, so now let's look at network logs. Network logs are going to be logs that are coming from a network-based appliance. We can analyze them using numerous sets of tools. TCP dump is one of the more common ones. That's a command or a terminal filtering tool. It's a packet analyzer. It's a packet filtering. It can display packet captures in real time, and it can write packets that are captured to a data file. Wireshark is a GUI built on top of TCP dump. The structure of TCP dump captures the varies depending on the protocols that are captured. Again, it doesn't matter if it's Wireshark or TCP dump. They do the exact same thing. The big one is TCP dump is terminal. Wireshark is a graphical or a GUI version of it. You can capture live data, save it to a PCAP file, and from there filter data as necessary. We have a Netflow. Netflow is a protocol that was developed by Cisco as a tool for network troubleshooting and session-based accounting. Basically, Netflow provides an important set of services. They can look at how traffic is related to what's going on with the network. It looks at accounting, usage, network billing, planning, security, DOS, and network monitoring. It provides a higher level detail of what's going on. It provides information about the network user, application, and peak usages. It records information about the packet flow, including all of the metadata. Cisco developed Netflow, and then it allowed it to be used as a basis for the EATF standard called IPFIX or IPFIX. Netflow information can be viewed with tools such as nfdump. nfdump provides a command terminal for viewing Netflow data, and it does it from a nfcapd captured daemon or a collector. Essentially, instead of doing a pcap file looking at our packets, our Netflow does something very similar, and they'll use their own specific tools for viewing them. With our packet captures, we have TCP dump. With our Netflow dump, we have nfdump. Here's an example of a basic Netflow record. It's in two different formats. We have a date, our flow structure, we have our duration, our protocol, our source and destination, both source IP, source port, destination IP, destination port, and flags. A large number of attributes follow a flow that are available. So IANA register of IPFIX entities will list several hundred, with the first 120 being the most common. Netflow use useful tools in the analysis of network security incidents, and it can be used to construct a timeline of a compromise, understanding individual host behavior, and so much more. Again, same thing with our Wireshark, it's just Netflow looks at a different set of data as it relates to our network. When we're looking at our data flow, one of the big things is visibility. And so we also have things like an application visibility and control system, which will combine technologies to kind of help review what type of applications are running on the network. Are they video? Are they voice? Is it email, file sharing, P2P, cloud, what? And so we have these control systems that kind of help with that. The AVC system uses a next generation network-based application recognition version. It's called NBAR 2, and that's known as the next generation NBAR, to discover and classify application based off of port data on network. NBAR 2 application recognizes over 1,000 different network applications. Again, the entire point here is to look at data flow on the network and understand what applications are using that data. From there, we can build better metrics to see the flow of data through our network. Alright, so now let's look at how all of this fits together. We have application recognition using NBAR. We have metrics to collect. That's going to be a combination of our Netflow. We have management and reporting through our SIMs and SOARs. And we have control with our QoS. So these different technologies together allow us to build a better, more versatile, and better secured network. We have our ability to manage traffic through port monitoring versus application monitoring. Port monitoring looks at the port number, and application monitoring looks at applications that are going through the network. They will be different depending on what you're trying to accomplish. If you're more curious about what type of data is going through the network based off of ports, then it would be port monitoring. If we're looking at what applications are running on the network, then we would do application monitoring. It doesn't have to be one or the other. It can easily be both to get different views of the flow of traffic over the network. Here we have an email security appliance and web security appliance through Cisco. Our different reporting features show a detailed, and a more targeted report. Again, all of this gives us our dashboard for reviewing our structure of the network. It also gives us the flow or a visual confirmation of the traffic flow through the network. We have our logging from other Cisco devices. So if we're looking at a Cisco iOS type device or even a firewall, we have our timestamp, we have our Cisco facility, we have our severity level, we have a message ID, and then we have our message text. And that's going to be pretty similar based off of all of our Cisco devices. Again, normally we're looking at the date time, then it'll give us our facility, and then after that there will be a number. That number is the severity. The lower the number, the more critical it is. We also have our proxy logs. These are servers that are used for web or DNS requests. They contain very valuable logs, and they can be a primary source for data security for our monitoring. These logs can then be analyzed to determine which hosts are making the requests, what are they requesting, how often are they requesting, and from there we can look for either learned behavior or seeing what they're requesting, and if it's malicious content, then we can mitigate accordingly. It is possible to use our web proxies to inspect outgoing traffic as a way to prevent data loss prevention, or to use some type of DLP mechanism. DLP involves scanning outgoing traffic to detect whether the data is leaving the web contains sensitive, confidential, or secretive information. Office 365, Google Business all have DLP functionality built in. If it detects PII, for example, there's a way to flag it so that the data doesn't actually leave the network, and instead it gets recalled, and then it can alert, the sender and maybe the sender supervisor saying, hey, this is what happened, this is why this email wasn't sent, and whatnot. Cisco has the program called Umbrella, and that was formerly OpenDNS, and that was offered open or hosted DNS services through the OpenDNS platform. This basically allowed us a way to filter certain content so certain DNS queries wouldn't actually be responded to. For example, we would do OpenDNS at our education institutions so that pornography-based URLs would not be allowed in. The DNS query just wouldn't look them up. Here's an example of a DNS proxy log as it appears. We have, again, date timestamp, the username, the AD site, the network, and what they're trying to accomplish. Normally we're looking what type of record we're looking up, and then the URL we're trying to look up as well. After that, we have our next generation firewalls. Again, these firewalls extend the network security beyond the IP and layer 4 ports. They can also work within the application layers and beyond. One function is reporting dashboard. Basically, the next generation firewall can feed into a SIM, but it doesn't have to. You do not need a SIM if we have next generation firewalls, but a SIM is still very useful. Again, the purpose of the SIM is to provide a centralized location for all of our logs. With next generation firewalls, they have things like firepower services to consolidate multiple security layers into a single platform. So we're going to say it's a hybrid SIM without calling it a SIM. Firepower services will include application visibility, control, IPSs, reputation and category URL filtering, as well as malware protection, all built into one. Again, it's a glorified SIM, just not calling it a SIM. Our next generation firewalls have the ability to collect connections, intrusions, endpoint, discovery, and Netflow events, and more. We have a packet tracer looking at Netflow. We have a packet tracer looking in our logging from multiple sources. And that is all we had for this chapter. We looked at IDSs, IPSs, we looked at how our logs can dump into different security appliances using Security Onion, how Security Onion is using the NSM-based tools, how Snort and other tools can be viewed and searchable through things like Skule or Cabana. We also looked at session data as well as log data. We looked at how full packet captures contain actual content. We looked at statistical data for creating an analysis. We looked at host-based and network-based logging. We looked at syslog servers and it kind of gave examples of them. We looked at DNS proxies, and we kind of started wrapping it up with our SIM and how our SIM functions. After that, we looked at our packet capture tools like TCP dump and NF type dump, as well as application visibility using InBar 2. We wrapped up with our email security appliances and web security appliances and how they kind of built into our SIEM or our other next generation firewall appliances for better review of what's going on in the network. Alright, any questions, any concerns, please feel free to reach out. Thank you. If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.